So I titled my talk as air quality management in India because I was thinking to keep this talk, as an overview talk to give the perspectives of air quality management, talk about what are the challenges faced in India and what are the opportunities, especially for the early career scientists or students who may be listening to this. I want to acknowledge also the contributions of my collaborators from abroad and India and my students and funding agencies. So what I will basically show in the next 30-35 minutes is a kind of an overview of the work my research group has been doing for the last 8 to 10 years on air pollution. So why are we actually concerned about air pollution? The answer is very simple, that we know air pollution impacts our health. And today, if you look into the health, we realize that now the focus has been shifted to non-communicable diseases. In fact, in India, if you see that 64% of annual mortality or death occurs due to non-communicable diseases. And out of the non-communicable diseases, 5 major diseases are listed here, which you can see, like cardiovascular disease, chronic respiratory disease, cancer, diabetes, and mental conditions. And because and it's not just the highest proportion of death, but if you really see what is happening is that 37% of the non-communicable disease related deaths occur at a very early age. That is why one of the major sustainable development goal targets set by WHO is to reduce these deaths by 1/3. And if we have to do that, we must realize what are the major factors contributing to the non-communicable diseases. And if you look into the factors, you can see that air pollution is one of the 5 major factors identified medically. What are the other factors? You can see that other factors are unhealthy diet, tobacco, alcohol, and physical inactivity. So clearly, air pollution plays a major role, not just in India, but globally also. And when you talk about air pollution, you all know that there are multiple pollutants, but the most important pollutant which has been talked about is fine particulate matter, or PM2.5. Now, why PM2.5 and what is PM2.5? I hope that whoever is listening has some idea, but just for the sake that these are the particles smaller than 2.5 micron. Now, how fine is 2.5 micron? You can see that a human hair is typically 50 to 70 micron in diameter. So you can actually put, almost 20 to 30 such particles on a human hair. So these are so fine. And what happens is that when we breathe, these particles go all the way into our lungs. And from there, it enters our bloodstream and then lead to several diseases. I just want to highlight 2 important numbers here. The WHO air quality guideline is set at 10 microgram per meter cube. That means, according to WHO, that at annual scale, if the PM2.5 concentration is less than 10 microgram per meter cube, there is a minimum risk. Anything above 10 microgram per meter cube concentration means the risk of developing some of the diseases, which I will come in a minute, increases. However, you must note that the Indian standard is set at 40 microgram per meter cube, which is just 4 times than the WHO standard. And why 40? Because obviously, if you see the condition in India, we realize that we cannot suddenly go all the way down to 10. So first we try to reach 40, and then once we meet 40, further, the step would be to reduce these national standards. I will again talk about, where are we and what are the major challenges in meeting even the national standard at this moment. Other than PM2.5, I must mention that ozone is another very important pollutant for which a lot of studies have been done, especially establishing the health impact risk factors. Now, for PM2.5, if you see already, as I said, medically, there is clear evidence exists that PM2.5 impacts a series of cardiovascular diseases, lung cancer, respiratory diseases, and there are also emerging evidence that PM2.5 exposure impacts our cognitive behavior like IQ, various other things, and then there is a whole range of metabolic disorders, and there is a range of adverse pregnancy outcomes. And as we speak, new studies are coming up clearly establishing that PM 2.5 exposure is linked to almost all major non-communicable diseases today. Now, if you see what is the status or what is the relative priority of air pollution as a health risk in India, you realize that again, air pollution stands as number 2 in the moment, just after the child and maternal malnutrition. So it has been established without any doubt that air pollution is a major health risk factor. So if that is the case, then what is the challenge India is facing in dealing with air pollution? And in fact, before going to the challenges, I thought to quote WHO Director General, who has said that the world has turned the corner on tobacco. Now it must do the same for the new tobacco, the toxic air that billions breathe every day. I believe why this is a very important quote, because there is a lot of similarity between smoking and air pollution. And in fact, and unfortunately, what happens is that if you talk to people, you realize that while there is no doubt that smoking impacts our health, perception-wise, if you talk to general audience, even or even the policy makers, there is a kind of sense of disbelief that air pollution may also impact our health, although there is plenty of research exists. And that is one of the major challenges that I highlighted here. So if you really see the challenges in India, in fact, you can divide these major challenges into 3 groups. First challenge is monitoring and management challenges. Now in India, I will again dwell upon on this particular aspect. But in India, we do not have adequate ground-based measurements for air quality, and that actually leads to a situation where we simply do not know how bad is the air in large part of our country. Then there is a group of challenges related to policy and governance, especially in terms of the implementation hurdles, monitoring the progress of some of the policy measures which have been undertaken. And then there is a whole different range of problems or challenges rather in terms of awareness and capacity. And what I was mentioning in the previous slide is that there is a general lack of belief that air pollution may impact our health, even if you talk to general audience, policymakers, and even some doctors. Although there are clear-cut clinical evidence exists. However, if you talk to people, nobody doubts that smoking, impacts our health. And why is that? Because, air pollution is kind of a silent killer. You do not see any health impact immediately. And that is why, it's very, very difficult to convince. And I will again, talk about this, what are the uncertainties, what are the challenges in that. And also, we have actually a limited resource in terms of skill, in terms of financing in battling the air pollution. So we have all these different challenges, but I think that at this point of time, India is uniquely positioned to address these challenges. And there are a lot of opportunities which I hope to bring out in the next 15-20 minutes. So first, to start with the challenge in monitoring and management, what I mentioned is that India does not have adequate ground-based monitoring. So if you follow WHO guideline, you see that WHO typically recommends that there should be at least one reference grade ground-based monitor per 1 million population. And this top figure shows what is the global status here. I have just listed some of the countries. For example, USA have almost 3.5 monitors per million population. But if you see India is lagging way behind. We have only 1 monitor per 7 million population. And even today, when there are almost 220 continuous ground-based monitoring under Central Pollution Control Board network, plus few hundreds manual monitoring, we have not covered any rural area. So all these monitorings are occurring in the cities, and most of the cities, they do not have more than 1 or 2 monitoring sites. So imagine a city like Indore, which has a single monitoring site. We may not know whether that particular site is representative of that city or not. Now, Delhi being the capital, obviously has the highest number of ground-based monitoring sites, but it's not the case. And as I mentioned, we do not have any monitoring going on in rural areas. We do not have any idea what is the pollution level in the background. And if you see that what is the estimated number of reference grade monitor, we come to a number of around 4,000, which means that we need almost $1 billion to put this reference grade monitor. So clearly that's not the path India should follow. And that is why we, and especially my research group, specializes in looking for alternate methods. And one of the major alternate methods turned out to be the satellite data. So what we did is that we established a methodology or an algorithm to convert satellite derived product like aerosol optical depth, which is basically a column integrated information, to surface PM2.5 using a dynamic scaling factor. I'm not going into details about the algorithm itself. You can get these references for more information. What I want to point out here is that our objective was to utilize this satellite data, which are freely available, and establish a PM2.5 database for the entire country. And we are very successful with the funding of Central Pollution Control Board. And now we have a 20-year of PM2.5 data from 2000 onwards at 1 kilometer spatial resolutions. And this two figures shows, that after we do adequate quality control, bias corrections, you can see that for more than 34,000 points, how good is our satellite-based data with respect to the CPCB data. And in fact, if you talk about annual scale concentration, then we have reached to a correlation coefficient of almost 0.98 with a very low root mean square error. But this allows us to look into the pollution from a completely different angle. Now we are able to see what is happening, how the air pollution has changed. And I must mention at this point also that in India, PM2.5 measurement at the ground started only in 2009. And if you look around for the data itself, you will realize that only after 2014-15, we have decent amount of data. So with ground-based data, there is no way you can actually establish a long-term trend, which now we can do with this unique data set, which is, and in fact, we are developing a portal called SANS to disseminate this data to anyone who wants to look at it, play around, and see how pollution in his or her particular area is changing over time. So very quickly, I want to show how we can use this data. So you can see that we can look into how the pollution level in India changes from season to season, and each season here is a 20-year average. So for example, you can see that in winter, you have very high pollution level almost everywhere. Again, reminding you that the Indian standard is set at annual scale is at 40 microgram per meter cube. So you can see that winter, in the entire Gangetic Plain and some part of the central India, the pollution level is typically, around 150, 200 microgram per meter cube. You come summer, March to May, things are much better. Although you have this continuous source of dust here in the dry area, but most of the other places, actually, the pollution level reduced to 60 to 70 microgram per meter cube range. Come monsoon, rainfall starts, it washes out pollution, which is non-factor. And you can see that how clean India becomes during monsoon. Now we are in the range of 30 to 40. And when looking into such kind of data, it also establishes how good is our alternate method of monitoring, this PM2.5 from satellite. And then again, from post-monsoon, October, November, you can see that we are back to this high pollution episode. And just for your information, like what we found is that, in 2017, almost 3/4 of Indian population does not meet even Indian standard. Forget about WHO standard. We also looked into how PM2.5 is changed, in decades. So from 2001 to 2010, you see that mostly pollution level has increased in the range of 5 to 10%. However, in the last decade, the increase even is more. And another interesting thing is that in the previous slide, if you have noticed that the Indo-Gangetic Plain is obviously the most polluted places. But when it comes to the rate of change, in the central or peninsular India, in fact, the pollution level has gone up much more than what actually changed in the Gangetic Plain. And so it tells basically is that what is happening in the last 20 years, initially the pollution problem was seen as a kind of Delhi-centric problem, but slowly now it became a national problem. And that is why exactly, the Ministry of Environment, Forest and Climate Change launched this National Clean Air Program with a target of reducing the pollution level in the major cities by 30% in the next 5 years. Again, with this data, you can look into very details for city or a rural area or anywhere else. So very quickly, if I go, we looked into how pollution builds up in Delhi. And so here we can see actually that x-axis is week, and each week is basically 16-year average. Y-axis in blue is your pollution level. The red indicates the fire count in the states of Punjab and Haryana, and this black line indicates the meteorology or boundary layer depth, which indicates whether the weather conditions is conducive for pollution to be dispersed. So what you notice here is that as soon as the monsoon is over by the end of September, your boundary layer becomes very shallow. That means the atmosphere becomes stagnant, and you see this increase in the pollution level. And you can see that typically it reaches somewhere in between 400 to 500 microgram per meter cube. And this is the typical peak pollution episode. Now media is referring as Diwali and other things, but I just want to point out this entire episode spans over almost 3 weeks. So it's not just related to one or two particular event, but it's a combination of many events. Especially you can see that the weather gets worse. You see this peak in fire count, which indicates that additional open burning is going on. And then again it comes down at the end of November, but again we have a second peak coming up in December to January. And then obviously as the weather conditions improve from March onwards, you see the pollution level slowly improves. But it never goes below the Indian standard, or hardly you will find in Delhi days where actually we meet the national standard. There is another way of looking at this. So what you are here seeing is the relative roles of emission and meteorology. So what I have plotted here is that the anomaly in emissions in y-axis, and anomaly in PM2.5 over Delhi region in y-axis, and I'm showing x-axis the months. So if you just focus on this September-October period, you see that in terms of emissions from Delhi, there is not much change. However, the moment you come to concentration, you can see there is a massive increase in the pollution level in October. So this October-November peak, which you see, which you have seen earlier, is clearly governed by both meteorology as well as excess emission from the upwind states. However, if you see the second episode, which is basically in January, and where you can see that there is a high emission anomaly related to very high concentration. There also you see that in terms of emission from Delhi itself, it's not very high, or in terms of anomaly, it's only 4 to 5%. But in terms of concentration, you can see that during this period, you have concentration 40 to 50% higher than the annual concentrations. So clearly, this kind of analysis establishes the important role of meteorology, which we often forget. As I mentioned, we have 20 years of data. Look into long-term change in Delhi. So again, keep in mind that in Delhi, we started measuring PM2.5 only in 2009-10. Before that, we do not have any ground-based measurements. We looked into our data, and what we found interestingly is that, again, I have not plotted the absolute value because the relative scale is more important here. So each year you can see what is the relative scale with respect to 20-year average. But I want to draw your attention here that what we found is that the pollution level was increasing from 90s, reached a very a high concentration around 2002-3 when CNG was implemented. And you can see immediately that after CNG got implemented in Delhi, there is a reduction, or this trend has gone down, at least for the next couple of years. But again, the pollution level started increasing, and we are back here. And then, from 2014-15 onwards, real efforts actually have started in Delhi. And just to keep in mind that, now we have implemented this graph in 2018. So again, this kind of data will allow you not just for Delhi, but for any place to see how things have changed in the past in terms of emission, in terms of regulations, in terms of meteorology, so on and so forth. So now question is that, if that is the real situation, so how can we meet national standard? So now we are coming to the policy from science. So what we did is that, a couple of years ago, we did this work where we tried to see that what is the target to reduce the pollution level to meet at least the national standard. And this is what actually we found, that all these districts which are in white, they are already below national standard. That is 40 microgram per meter cube. But obviously, as you have seen that, most problem is in the Gangetic Plain. And what we notice is that, in the Gangetic Plain, you need to reduce the pollution level by at least 40 to 50%. Which is a humongous task. Then question comes that you can target in number of sources, but what is the ideal source in terms of implementation, in terms of cost effectiveness and all. And then it turns out that household emissions have a very large impact, especially in the districts mostly which have high rural populations. And this figure shows you what is the percentage contribution of household emissions from cooking, from burning, kerosene, from heating, to the ambient PM2.5. And you can see that mostly, in the Gangetic Plain, this number is somewhere between 30 to 50%. And it gives us idea that what if we mitigate household emissions and what will happen. And this will happen. So if we mitigate completely emissions from all household sources, all the districts in blue will meet national standard. And even if the districts in Gangetic Plain, you can see that they are not meeting the national standard, but except Delhi, NCR region, and few districts in the Western India, now we are in touching distance of meeting the national standard. So clearly, this is a very important policy information. And this is not just our study, but there are at least 7 or 8 studies done by different groups. And we again did a policy paper where we found that across all these studies, clearly the contribution of household emissions to ambient PM2.5 is much more than contribution from transport, power plant, and industry combined at a national scale. But keep in mind 2 important points. One is that now we have implemented this beautiful scheme called Ujjwala, and in near future, obviously, we are expecting to reduce the contribution of household emissions. And why that is happening, and when that is happening, obviously the other sources like transportation, power plants, industry, and various other like open burning, these sources will become very important. That is number one. Number 2 important lesson is that we need to ensure that household emission actually comes down. And that's where the second problem or second challenge comes, the implementation. We have this policy, but again, the ground report suggests that not many households are actually using the LPG given to them. So we again need, massive awareness campaign to ensure people actually use it. And then only we'll see this benefit coming. Then important question, as I mentioned, while we are trying to address the household emissions at regional scale, we need to talk about other sources. And now there are plenty of studies available in India at national scale, at regional scale, at city level scale about very detailed source apportionment. And I just borrowed this from a good friend Sharath, who is looking into 50 cities. And you can see, just for example, what is the distribution of emission in terms of sources in 2 cities in Eastern India, Jamshedpur and Kolkata. And also what is the contribution for each of these sources to the PM2.5. So again, important point here is that you can see there is a very large fraction of transboundary transport to keep in mind in both these places, which suggests that, a city cannot reach to its target unless the upwind places cooperate. And that's what actually, talks about the importance of the regional cooperations. And this is very important in a framework like National Clean Air Program. My point here is that, such kind of information is now available for air quality management. All we need now is a plan which is implemented properly. Then comes to the last part of my talk, that is the health benefit analysis. Now, why it is required? Now, when you talk about air pollution or any target set, the question often comes is that, okay, if we try to reach 40 microgram per meter cube, what kind of health benefit are we expected? Now, how to answer this question? So, for quite a long time, there are a lot of discussions about how to do the health benefit analysis. Eventually, a uniform framework evolved under Global Burden of Disease Initiative, who actually developed this methodology to calculate what is the mortality or morbidity burden attributed to a particular level of pollution. And how they do that? So typically, you can see that health burden depends on three factors. One is the baseline mortality. It means basically the incidence rate of a particular disease caused by any factors. Like, it's not just air pollution, but all the factors I talked about earlier, like smoking and various other things. Population, like what population is actually exposed to a particular pollution level. And the third factor is relative risk. That means what is the risk of getting that disease, or what is the risk of mortality attributed to a particular level of pollution. So all these three factors are very important in that calculations. Question comes that, and the most challenging of it is actually how to calculate this relative risk, because baseline mortality is actually captured in health survey across the countries, and population data anyway is there in the census. So, and then if anyone wants to know more about GBD, I recommend reading this book. This is a very fantastic book. So, relative risk typically depends on chronic exposure to pollution level. Now, how it is done is that, so what we are basically looking at here is that, we have relative risk, but we want to know how this relative risk increases as the exposure to PM2.5 increases. Now, it is done typically based on the epidemiological studies. So we have a group of epidemiological studies done, across the world for ambient air pollutions. Don't take like there are 3 studies. It's just a sort of rhetorical, graphical representation. So there are, I think, more than now 120 studies done globally, talking about the health risk due to air pollution. Then there are a group of studies done for household air pollution. And then we have, studies done for passive and active smoking. And you can see basically what is happening is that as you come from ambient air pollution to smoking, what is only changing is your exposure range. So your typical ambient air pollution range is somewhere between 3 to 100 microgram per meter cube. And when a person is actively smoking, the exposure range is something 10,000 microgram per meter cube. So now question comes that if I have to calculate, especially if you talk about India ambient air pollution level PM2.5 is somewhere here. So how do I calculate what is the risk associated with this particular level? So one way to do it is that we develop a linear function and we simply extrapolate the ambient air pollution studies and calculate the risk. However, if we do so, people found out that then we'll end up with abnormally high risk for smoking, which is not realistic. And that led to a formulation of a non-linear risk function, which basically integrate all the studies done from ambient air pollution to smoking. The challenge here is actually that how do we define such non-linear function? However, there are actually ways to do it. I will not go into details. But for a moment, just take that now we have these nonlinear response functions. And once you have these nonlinear response functions, then you can calculate the relative risk corresponding to any level. And using that, in fact, what we calculated is that how the mortality burden in India changed from 2000 to 2015. And if you see in India, this axis is in percentage. So what we found is that air pollution related mortality burden in India increased by almost 48% in the last 15 years. However, as I mentioned, that it's not just the pollution level, but also the socioeconomic conditions. So when we tease out individual factors, what we found is that the mortality burden due to air pollution only by 15% due to increase in the pollution level itself. This large increase is mainly because the population has gone up in this time, as well as the age structure has shifted towards the older age. And keep in mind that the risk increases when a person ages. So that means the risk at the age of, let's say, 30 to 40 years is much lower than for the same disease than the risk at, let's say, an age of 60 or 70. And because of these important, socioeconomic conditions, what we found is that if we really want to reduce air pollution burden in country like India, it's not just deal with air pollution, but at the same time, try to improve the baseline mortality. In fact, in India, what happens is that in the last 15 years, baseline mortality rate has gone down because there is a massive improvement in the overall healthcare program. And if such improvement continues, we expect this to partially counterbalance the impact of air pollution. This is important. Now I want to bring this idea that the challenge for policy is that there is no direct evidence. When you say that 1 million people die for air pollution, you cannot validate this number because no death in India has air pollution as a cause, because also you keep in mind that air pollution is not a cause of death, but it is a risk factor. The same way, no death can be directly attributed to smoking. So the challenge here is that since you cannot directly validate whether it's 1 million, and also what we notice is that these risk functions, what I mentioned, that how this, for example, this is the risk of chronic pulmonary disease. You can see that over the years, the shape of these risk functions also have changed. And if such thing happens, and if you keep everything remains same, still you end up with varying estimates. Like if you use this risk function, which is IER 2010, your calculation will be around 800,000 deaths attributed to air pollution. If you go to this risk function, IER 2015, the number will be slightly lower. With IER 2017, it's even lower. If you go to GEM, it's very high. So the point here is that since there is no way to validate what is actually the true risk functions, we need to frame policy keeping in mind and in a way that we extract meaningful science. And we are working on there, and we are proposing actually an ensemble approach where irrespective of the risk functions, our proposal or our suggestion is that if you look into qualitative way, you can find that still no matter which risk function you follow, it's always this yellow portion which is very high, which is basically ischemic heart disease. And again, due to paucity of time, I'm not going into much details, but I want you to keep in mind that this is very, very important aspect of it to establish a benchmark. And when you talk about impact, keep in mind we are talking about chronic impacts. There are also studies done with short-term impacts, for example, looking into all-cause mortality. And again, and also like, looking into the impact during pregnancy. And you can see that all the Indian studies are in the same range as of the studies done in the Western world. And so, and although the pollution level in India is 5 to 10 times higher. So when you look into such evidence, what is emerging is that, probably we need to really now think about establishing a proper counterfactual concentration for India. Start thinking about the issue of toxicity, because in India, we have so much background dust present, and we simply do not know whether the risk due to dust is same as of the risk due to vehicular emissions, which has mostly nitrogen oxides, black carbon, and other stuffs. And this issue of toxicity is the new frontier, and there is a new NASA mission coming up, which I'm part of, called Maya, which actually targets to provide a speciated PM2.5 product, which will settle this discussion. Last, I wanted to highlight that how it is looking for the future. So very recently, we published a paper looking into the future. And what I found is that if no major policy is undertaken, so here what you are seeing actually again is the change in PM2.5 in percentage, all across the years or in terms of decades from the pre-industrial time. So you can see basically in India, pollution, and this the reference period is 2000 to 2010 decade. So mostly in India, pollution level really did not change much. Only it started increasing from 1970 onwards when India started, massive urbanization drive and industrial drive. And if no major policy is implemented, you can see that for the next couple of decades, it's expected to increase. And the different colors, if people are familiar with climate change, are mainly two different climate change scenarios. RCP 8.5, which is in red, is the more severe. But such changes will come with some climate consequence. So we did some study also to understand this. Very quickly, I will go through is that, so we'll try to see what will happen in 2030 if we follow a baseline emission scenario versus a mitigation emission scenario. Basic difference is that in baseline emission scenario, you can see that the emission of the pollutants is increasing most of the places. However, in mitigation scenario, there is a large reduction in the pollution, emission of the pollutants. And if we follow baseline versus mitigation, this is the simulations we did. You can see that for baseline emissions, the pollution and pollution level of atmospheric PM2.5 will increase from the baseline year 2010, 41.4 microgram to 61 or 58. However, if we follow mitigation, it will remain same, although the several things will increase. However, what we found interestingly is that if we follow mitigation scenario, there will be additional 0.3 to 0.5 degree warming. And so in other words, if you remove these particles from the atmosphere, because most of these particles scatter sunlight and cool the climate, so you will get basically this additional warming. And that's the trade-off we need to really see. And what we found is that, following this mitigation scenario has a benefit, and it will avert almost 380,000 deaths. So now it's a trade-off, like, will we allow half degree, additional warming versus 380,000 lives saved? And again, this is a very important policy dilemma. Last, I want to end my talk with this key lessons learned during lockdown. I just thought to show one important slides. So let me explain this. You can see basically, how the pollution level has changed from March 14, and our reference period is again 14 to 21. So this is basically an anomaly scale. So what I want to point out here is that, there are many studies reporting air quality improvement and stuff like that. In my opinion, obviously, that's not a surprising, because we expect air quality to improve because most of the sources are not operating. I believe what is even interesting is that why it has not improved to the level expected. In fact, if you see really what is happening is that, yes, the moment lockdown started, there is a massive reduction in the pollution level in almost all these major cities. I have actually the data for the entire country, but I'm just showing few cities. But again, you see now many of these cities, the pollution level have started going up. And in fact, if you really see, during this period, April 11 to 15, it is again back to this pre-lockdown concentrations. What is very interesting to me is actually the data from Varanasi. I do not know exactly what happened, but in Varanasi, what I notice is that even during lockdown, the pollution level kept on increasing. At this point, we did not do any further analysis, but I think these are the interesting things we should really look into, like what is causing this kind of regional variation? What is the relative role of meteorology? Is it long-range transport, which is jeopardizing the lockdown benefit in Varanasi? How much locally the emission has reduced? So I think there is a lot of interesting lessons one can learn and further discuss, with more data and all. So I just want to conclude my talk is that hopefully I convinced you that there is enough evidence of staggering health burden in India, and in my opinion, we do not need any further scientific evidence, at least to take action. And India has launched several policy measures in the recent past to address this issue. And in my opinion, the key actually would be effective implementation. And this is the major hurdle currently faced in India. That how do you implement and ensure actually that the implementation is maintained and there is a proper mechanism to monitor the progress. And lastly, I want to point out from research perspective, especially for the students and early career scientists who are here, that India, I think, should invest in exploring these new frontiers like the issue of toxicity, long-term cohort studies, because keep in mind that we really do not have long-term cohort studies in India, really to look into the biological mechanism of how air pollution is impacting the health. So I will stop here and I'll be very happy to answer questions now.